Hello and welcome to this video called Writing Recurrence Relationships in Symbolic Form. Whoa! Yeah, I know, these titles get longer. My name's Darren from Maths Guru. Thanks very much for joining. Hopefully it's not because you've been forced to. But if you have, do me a favour. Can I force you to sign up to my YouTube channel? I know, it's a bit weird, but the point of it is I don't know whether anyone watches these videos. And the only way I can do that is if you click subscribe. So if you can do that, that would be greatly appreciated. I'm also on TikTok and all those other things as well. So if you can sign up over there or follow me, awesome. And I'm probably going to be live streaming, so you may look out for those as well. Now what I'm going to do, I always start with the learning objectives to be able to number and name terms in a sequence. So we're building on the lesson we had previously and be able to generate a sequence from a recurrence relation. And recurrence relations become really big in this course, and particularly in year 12. So let's recap what we did last lesson. In the last lesson, we looked at what a sequence was. It was basically a list of numbers that followed some sort of a pattern or rule, and I use that advisably in a moment, that allows us to create one number if we know the previous number, for example. Okay, so if it was an add 2 rule, for example, if I had a +2 rule, he says writing in highlighter, and I knew my start number was 10, then I basically would know my next number is 12, then 14, then 16, then 18, ... and those 3 dots means my sequence goes on to infinity and beyond. So by knowing what my start number is and knowing what my rule is, I can create a sequence of numbers. And sequences can be multiplied and divided and added and subtracted and all sorts of things, right? Now, notation is going to become really important as we get through this course. And if you unfortunately stuff the notation up, we're going to be in all sorts of problems. So, the positions of a number in a list that can be numbered. What on earth does that mean? Well, when I'm in a dinner queue, if I'm at the very front, hello, I'm first in line. Thank you very much. The person behind me is second in line. The one behind that is third in line. And hopefully, no one's going to cut in front of me, or I'm just going to push them out of the way. We don't cut in. So numbers in a sequence can be given a name, if you will, right? So the positions can be numbered. Now, to make things nice, we can actually number these things starting at 0, all right? So later on when you get to General Maths in year 12, 0 means that basically it's the initial amount, it's the opening amount. We might open a bank account with $20,000, for example. So making sure that all our sequences start with that little subscript of 0. Now what do I mean by subscript? There is a T and it's got to be a little 0 there. Sadly, if I write T with a big 0, I'm actually going to be wrong. If I write T with a floating 0, it is going to be incorrect. Now these notes that I'm writing on you can download, by the way, from mathsguru.com. Sign up, it's absolutely free. And you can write all over them because all I do is use them as a guide. You may go, oh, that was really important, write that down, or just use your summary book. So having got my start term, which I just said was T with a little subscript 0, the next term would be T1, and then T2, and then T3, and so it would go on. Now, how is this going to be important to us? Well, basically, we start using this in a moment in what I've called a recurrence relation. So let's go to our sequence. We've got a sequence here with the numbers 54, 50, 46, 42, 38, 34, 30, 26, ... which means it goes on. Now, our term number here is 0. For remember, our first term starts at 0, then we have 1, 2, 3, 4. So we can now say that T0 equals 54. That's my start number. And that's going to be useful to know in a moment. T1 would be the second number in my list. T2, the third number in my list. T3, the fourth number. And again, just to make it really clear, that first term is called term 0. Right, so here's an example from the Cambridge General Maths textbook. Thank you very much, Cambridge, for allowing me to use your questions. You guys absolutely rock. So we've got this sequence, 54, 50, 46, 42, State the values of T2, T5, and T7. So what the textbook suggests you do is write out the numbers. So 54, 50, 46, 42, 38, 34, 30, and 26. And then underneath that, write each of the terms, T0, T1, T2, T3, T4, T5, T6, and T7. Now, the point of it is, I probably wouldn't do that. I'll show you a shortcut in a moment. But we can now go and say, well, okay, my answers are that T2 is going to be 46, T5 is going to be 34, and T7 is going to be 26. Now again, you probably will turn around and say, well, hold on a moment, I can count. So if I call that 0, so that's 0, 1, that must be T2, which is 46. I'll do it on here. So that's 0, 1, 2, 3, 4, 5. Sorry, we wanted that one. 5, 6, and 7. Absolutely another way of doing it. I think they're just trying to make sure you don't make mistakes. Recurrence relations. Now this is the important stuff. Having just taught a live stream on General Maths for Year 12, I can tell you over and over again that if you understand what I'm about to show you here and understand what it means, you are smashing it. If you need to, copy this down, put it in your summary book, do what you need to do. But a recurrence relation tells you two main things. One, the start number of your sequence, and two, it tells you the rule to use to go from term to term. And that's what it is. A recurrence relation goes from term to term. So it's a term to term thing. Now, I'm going to come back later to the idea of what we call a position to term, all right, because you can actually do that a bit later on, but that's called a rule. Now, again, I don't want to get confused here. Rules are confusing, all right? Rules mean something very specific in maths. A recurrence relation is here. So let's have a look at what I've got here. I've got T0 equals 2. Well, hold on a moment. We just said that anything with a subscript of 0 is my first number. So, okay, that's now telling me write down my first number. So there's 2. What is the next bit now? Believe it or not, that comma there is really, really important. Please make sure you put the comma in. T with the subscript of n plus 1. Now, what I want you to realize that is, or to reread it now, or from now on to see that and go, ah, it means to get to the next number. So to get to my next number, that's the equal sign, T with a subscript n, take my current number, and then do whatever the maths tells you to do. In that situation, add 2. So my recurrence rule in this situation is basically to get to my next number, add 2. So 4, next number, 6, next number, 8, and so it goes on. Now you're going to turn and say, this is ridiculously simple. I agree. It gets a little bit more complicated as we move through the work. Right, so here's another example. Write down the first 5 terms. Believe it or not, in an exam, I cannot tell you the number of people who can't count to 5. I want the first 5 terms. So what I'm actually going to do is I'm going to write 1, 2, 3, 4, 5 lines. That is going to help me not stuff up, basically, not do too many numbers. So write the first 5 terms for the sequence defined by the recurrence relation. So T0 equals 30. What does that tell me? Oh, it's my first number. Okay, so there's the first one written down. What have I got to do next? To get to my next number, I take my current number and then subtract 5. So basically my rule is just keep subtracting 5. So 30 subtract 5 is going to be 25, then 20, then 15, and then 10. And believe it or not, that's ridiculously simple. And I would say to you, about 20% of the state will mess that up because they'll do too many numbers because they haven't read the question. And believe it or not, that's the end of this video. Short and sweet. Yes, or is that just me? Thanks very much for watching. There's a lot more videos to come in the series. Hopefully you found it useful. If you have, can you sign up and subscribe to my YouTube channel? Again, just lets me know that you're watching. Follow me on TikTok. Head over to mathsguru.com. There's the screen behind me that sort of shows you a little bit what it's looking for. Sign up absolutely free, right? There's downloadable notes, videos, and all sorts of stuff. And hopefully I'll see you in another video. You take care of yourself, guys. Bye-bye. Stay safe.